So remember, simple interest means interest is only calculated when there's an action on the account. So in this case, we start out, of course, November 28th. We need to look up in our little table what day of the year is November 28th. Everybody find that? What's that? 3/28. Good. Now while we're at it, let's look up the rest of the days. January 3rd, of course, is the third day. February 8th is what, 39? And March 7th is 66. Okay. So we are starting out November 28th is when the loan originates. The first action then is on January 3rd. And that is a $1,500 payment. That is, well, we have 365 minus 328 gives us that is 37 days from November 28th to the end of the year, plus the 3 days in January makes that day 40. So let's find our interest based on that. Let's scroll down. There we go. So our interest is based off of the $6,000 principal. Our rate of 8 1/4 is 0.0825 times 40 over, remember, unless it says otherwise, unless it says exact, it is ordinary interest, which is over 360. Which gives us $55 in interest. Does that look right to everybody? So what that means is it was 6,000 plus $55 equals $6,055 before the payment. We subtract, that was a $1,500 payment. You get $4,555 is our balance after the payment. When is the next action on this loan? Oh, that would be February 8th. On February 8th, what happens? $2,000 payment. So let's take a peek at what our time is. How do we find the number of days that we're going to use there? Well, February 8th is day 39, right? What day were we on? January 3rd was day 3, so 36 days have gone by. So that's the time we need to use. What's the principal we're going to use to calculate our interest? $4,555 times 0.825, perfect, times 36 over 360. $37.58 is our interest. So then we go to add that to our $4,555, which gives us $4,592.58. That's our balance before the payment. Then what? Subtract $2,000 payment $2,592.58 is our balance after the payment. What's next? March 7th, which is day 66. And what happens on that day? Paid off, right? So we subtract, February 8th was 39, so 66 minus 39 is 27 days. Then what do we do? Okay, so we've got 25, 92, 58. Then what? .0825, yep, and then? Perfect, 27 over 360. Giving us $16.04 in interest. So we'll get a final balance of 2592.58 plus 16.04 equals $2,608.62. That was the balance paid on March 7th. Second part, the total interest. How do we find the total interest? We got 1604, 3758 plus 55 adds up to $108.62 total interest. The final thing we asked you for here was the amount saved. To calculate that, we would first have to do what the interest would have been without the partial payments. So it's 6,000 times 0.0825. We have to figure out the days. We have 27, 36, and 40. So 27, 36, and 40 add up to what, 103 days? So that's times 103 over 360. $141.63 would be that interest. We subtract the interest of 108.62. We saved $33.01 by making the partial payments. Any questions? Those are long problems. So, when we left off last class, the problem we just discussed is what is called a simple interest note. And if we look at our timeline, the beginning and the end, a simple interest note, the face value is this amount here, the present value. Or, as we've often called it in simple interest, the principal. And of course, over the period of time, over the term of that note, that's the term, it accumulates interest, which is the P times R times T, PRT. And at the end of the note, there is a maturity value that is equal to the principal plus the interest. Before we left last week, we mentioned that there's a different kind of note that we are going to be discussing this week. And that is a simple discount note. A simple discount note also has a face value. Face value means that the amount that's listed on the note. But in a simple discount note, the face value is the amount that is paid back. The amount due at the end. There is still interest, but the interest is called a discount. And that is still equal to principal times rate times time. Only now we have to remember that the principal is that face value, the amount that's getting paid back at the end. So at the beginning, we receive proceeds. Those proceeds are the face value minus the discount. So let's take a look at how that would work. Sam borrows $6,000 on a 9% simple discount note for 120 days. Find 1, the amount of the discount. 2, the proceeds. And 3, the amount paid back. One of these answers should be real easy to answer right now without doing anything. Which one is it? The amount paid back is going to be how much? $6,000. The face amount of the loan in a simple discount note is the amount that's going to be paid back. So then, we're going to find the discount next. The amount of the discount is just interest, so it's our principal. 6,000 times our rate, 0.09, times our time of 120 over. It doesn't specify exact interest, so we're going to use ordinary of 360. So your interest of $180, that's our discount. So far, that looks just like the interest, the simple interest note. The proceeds is where it's different. So our proceeds are found by taking that face value of $6,000 minus that discount of 180 give us $5,820. That's the amount Sam actually receives. Now, last week we discussed a little bit as to why they would ever do a loan like this. Well, the big reason they do it is if there's some sort of collateral, something that's securing the loan, whether it is another account that you have that's coming due on a certain date, or money that, guaranteed money that you're going to have coming in, or even if it's just an item that's going to have a certain value on that date. They want to make sure that they're not going to loan you the amount of money that's equal to that value. They're going to loan you the amount of money that's less than that, so that when they add interest, it stays below that value. So that's why they do a discount note like this. One thing you will notice, however, they calculate the interest of $180 off of that full face value of $6,000. Do you get the full $6,000? No, you only get the proceeds, $5,820. So effectively, you're paying a much higher interest rate. So we have to figure out something called an effective rate. What would be the equivalent rate if this were a simple interest note with principal equal to the proceeds of the discount note. So we're still going off of I equals PRT. But now we know the amount of interest is that discount of 180 bucks. We know the principal, we're not going to use the full 6,000 because we don't actually get the full 6,000. We're going to use the proceeds, $5,820. The rate is what we are looking for. Our time, what was this, 120 days? Yes. It was 120 over 360. So this goes back to what we were doing in the first hour last week, just solving this equation. So the 180 over here doesn't change. We're going to combine the 5820 and the 5,200 and, or sorry, the 120 over 360. Where I got the. If we multiply that out, 5820 times 120 over 360, we're actually going to get an even number, which is nice. 1,940. So that's 1,940 R. What would our next step be? Yeah, we got to get R by itself, so we're going to divide by 1940. Now let's say I want the effective rate to the nearest hundredth of a percent. This is going to be very common if I do not specify otherwise in the problem. I want the effective rate to the nearest 100%. So that's something to make note of and keep track of. Since I want the effective rate to the nearest 100th percent, I'm going to round to at least 5 decimal places. Let me show you why. So 180 divided by, I know it's a nice round number, but I'm still going to use that answer function on my calculator. I get 0.09278. Notice that is 5 decimal places. Because that's a rate, make it into a percent, what do I have to do? I have to move it 2 spots. 9.278%. And we still have to make sure we can round it to the hundredth. That'd be here, so that 8 tells us that it rounds up to 9.28%. So effectively, even though that loan states that it's 9.28%, we are paying, or sorry, even though the loan states that it's 9%, we are paying 9.28% interest on it. I'm going to have you guys do some examples here quick. Let's say that Alex borrows $7,200 at 6.7% on a simple discount note for 90 days. Find the discount and the proceeds. I'll give you guys a minute to do that. So to find the discount, it is just I equals PRT. What's our principal? 7,200. What's our rate? 0.067. What's our time? 90 over 360. Giving us interest of $120.60. Does that look right? That's our discount. How do we find our proceeds? 7,200 minus that discount of $120.60 is $7,079.40. Do you guys concur? Cool. Let's have you try one more. On May 8th, Stacy borrows $3,500 on a 5.7% simple discount note to be repaid on August 5th. Find the discount and the proceeds. I'll give you guys a minute there. So what day is May 8th? 128? Okay. What day is August 5th? 217. So how many days is that? 89 days, yes. So our discount, how do we find it? Okay, what's our rate? 0.057 times 89 over 360. $49.32 is our discount. So then our proceeds are $3,500 minus the discount. $3,450.68. Correct? Cool. Well, then let's take a look at this one. Pat borrows $9,200 at 7.4% for 150 days on a SDN, stands for simple discount note, just because I'm tired of writing it out every time. So 150 days on a simple discount note. Find the effective rate. Well, asking you to find the effective rate is just a sneaky way of asking you to find everything else too, because we need both the discount and the proceeds to find the effective rate. Somebody taught me through finding the discount. Okay. Perfect. Oops. We get 283.67 for interest for discount. Does that look right? Okay. So proceeds, the 9,200 minus 283.67 gives us $8,916.33 for proceeds, correct? Any questions so far? So then our effective rate, we're back to I equals PRT. I is our discount, 283.67. P, we're going to use our proceeds, 8916.33. R is what we're looking for. Our time is 150 over 360. So now it's a matter of solving this equation. There's nothing to do on the left side. On the right side, however, we have to combine that $8,916.33 with our 150 over 360. This could give us an ugly decimal. So we need to leave that in the, actually it's not terrible, but we're going to leave that in the calculator and reuse it. So it's 3715.14 times R. So then we solve that by getting R by itself, so we divide by 3715.14. Now what I'm really going to do over here when I divide is I'm going to type in the 283.67. I'm just going to divide by that previous answer. So 0.0, where should I round that to? Yeah, well, at least 5 decimal places, sometimes even 6. This one, it won't matter, but we're going to go to 5, or let's go to 6 because I want to show you something. So 0.076355 equals the rate. So we move it 2 spots to make it a percent, 7.6355. Then we round it to the 100th of a percent right there. So 7.64%. I went that 6 decimal place, that extra decimal place, to show you if this had been like 4 or 5 here, we would have rounded that up to a 5, and then when we round it again, we would have rounded it up again. We got to be very careful with that. If that 5th digit is a 4, you want to make sure you go at least one more digit past that, just to be safe. So when I said at least 5th digits, that is 5 digits, that is a bare minimum. Let's have you guys try one for effective rate. So Peyton borrows $4,800 at 9.1% for 110 days on a simple discount note. Find the effective rate. I'll give you a minute. So what is our first step? Find the discount. So how do we find the discount? Our face value, 4,800, times our rate of 0.091, times our time of 110 over 360. Very good. Giving us $133.47. That's our discount. What's step 2? Proceeds. How do we find that? Okay, our face value of 4,800 minus our discount of 133.47 is $4,666.53. What is step 3? That is then the effective rate, which is I equals PRT. What goes in there? Okay, I is the discount, 133.47. The principal, we're going to use the proceeds, 4666.53 times R, and then times our time of 110 over 360. And then okay, we combine our principal and our time. So the 466.53 times the 110 divided by 360. We get an ugly decimal, 1425.88. Again, I'm not going to hit clear on my calculator. I was very careful not to do that, so that number is going to stay in there for me. So then my last step is, or next step is, Divide it. Very good. So we've got 133.47 divided by that previous answer, 0.093605. You can get quite a bit different, yes. Yeah, if you just use the 1425.88, it will be significantly different. So now we move our decimal point 2 spots to make this 9.3605%. Where are we rounding it? Hundredths place, that's the 6. 0 says it stays 9.36. 9.36%. What do you think? I think it's break time. Let's take our break. It's 6:19. Let's come back at 6:29. Okay, so the next process we need to work on. It's not a horribly difficult process to do, but it has a lot of steps, and it's called discounting a note. So we're going to take our time, and we're going to go through the first few examples pretty slowly, and then we're going to do a lot of examples to make sure you have it down. But what's going on here is there's 3 parties involved. Let's say that you are a supplier. We talked about it in the last unit. You create the products and you sell them to the retailer. So you're either the manufacturer or you're a distributor of some sort. And so you sell these products to me. And I buy those products. Remember, the invoice we have, it's 210 net 30 or whatever. And it'll say in the small print, the fine print on that invoice, if not paid on due date, will convert into usually they do something outrageous like a 12% simple interest note. What that means is on the due date, the end of that credit period, if I don't pay, it becomes a 12% note. 12 or 18% are the common percents used because they're easy to figure. 12% is 1% a month, 18% is 1.5% a month. And they're not going to give you a cheap rate because obviously they'd rather have their money. So what will happen a lot of times, in order to avoid this, let's say I am getting very, very close to the end of that credit period, I can't pay you. So I might arrange with you to have a little bit better term. So you arrange a 90-day simple interest note at, let's say at 8%. So I can pay a little bit lower rate. And let's say the balance is $5,000. So a couple of things usually happen. They're usually, I pay as much as I can of the balance due. So you're getting some of your money. In exchange for me doing that, we negotiate that you're going to give me that extra 90 days, but you are going to charge me interest. So you have this 90-day simple interest note. So at the end of 90 days, you're going to get the $5,000 plus interest. Well, let's say that somewhere in that period of time, let's just say on day 40, you need money. What are your options? Sell a kidney, right? You can ask me for an early payment. You might, and there are options here. You might say, hey, I'll waive all your interest if you pay me the $5,000 now. I'll give you a break on the interest or whatever. There are several options that could come in there to try to get me to pay early. But if I don't have the money, I can look at you and say, hey, I've still got 50 more days. I'm not paying yet. So then what are your options? Well, you can go to a bank. And you're going to go to that bank and say, hey, look, I need money right now. But I have this simple interest note that's going to be paid in like 50 days. Can you give me a loan based on that? And the bank is going to say, sure, we'll give you a loan based on that. They loan you money on that simple interest note. Now, one thing that the book describes that's a little bit off, the book describes it as selling the loan to the bank. You're not really selling the loan. You still own that loan. But what you have done is you've borrowed money from the bank based on that loan, and you have given the bank permission to collect that money. So you've given them, part of the contract is they have the right to collect that money directly from me now. You've gone to the bank, they've given you the loan, and then the bank will try to collect it from me. However, this creates something called a contingent liability. Does the bank have a contract with me? No. Who does the bank have a contract with? With you. If I don't pay, can the bank legally go after me? No, they don't have a contract with me. Who's the only person that can legally go after me? You. So my contract is with you. You're the one that can legally collect from me. The bank can try, but if I don't voluntarily pay, what's going to happen is the bank will collect from you. And then you have to come after me. So like I said, you still are the owner of the loan. You haven't really sold the actual loan to the bank. All you've done is borrowed money against it and given the bank the right, the power to collect it. So let's take an example of how this works. So let's say that Pat extends a 90-day simple interest note, SIN stands simple interest note, to Sam at 8.4% for $8,000. On day 40, Pat needs money for some reason, so Pat discounts the note to a bank at 9%. This 9% here is referred to as the bank's discount rate. The bank's going to charge you a rate for lending you that money. That's the rate the bank is charging you. So now let's look at this process. There are quite a few steps here. So the first step, step number one, is you must find the maturity value of the original loan, of the original note. So this is going to take place in two parts. We find the interest, then we add the interest onto the principal. So this is for the original note. How do we find its interest? Yep. Yep. Perfect. Our principal of $8,000 times 0.084 is our rate, times 90 over 360, giving us $168 in interest. Is that what you guys come up with? Okay. $168, good. That's our interest. We still have to find the maturity value, which will be the principal of 8,000 plus the $168. So $8,168 is the maturity value. That amount will become the face value of the simple discount note to the bank. That's how much we have coming at the end of the 90 days. So that's what the bank is going to loan us money based off of. Does that make sense? That's how much is going to be due on Sam's note. So when Pat goes to the bank, Pat borrows against that maturity value. Step two. Step two is where people typically make their mistake. Step two is find the discount period. Let's define the discount period. The definition of discount period is the amount of time the bank will hold the note. In other words, it is the number of days left until maturity. So how many days was this note? It was a 90-day note. What day did we discount this note to the bank? Day 40. 90 minus 40 means there are 50 days left. That is the discount period. Any questions so far? Anybody need more time to catch up taking notes? You good? Step three. Find the bank's discount. This is back to I equals PRT. where I is the amount of the discount, the principal is the maturity value of the simple interest note. So that maturity value was, remember, 8,168. The rate is the bank's discount rate. We said that was 9%. And our time is the discount period. Yeah, 50 days, so 50 over 360. 8168 times 0.09 times 50 over 360. $102.10. That's the bank's discount. Step 4. Pat's proceeds. In other words, how much is the bank going to give to Pat? So the bank takes that principal, $8,168. That's the maturity value of that original note that Pat made to Sam. They're going to subtract their discount of $102.10. So that means the bank is going to turn around and give Pat $8,065.90. That's how much Pat gets. So Pat still gets a little bit of interest on the $8,000, but of course loses a large share of it because Pat had to discount that, the bank. Let's do another example of this. Alex extends a $9,800 simple interest note at 7.8% for 120 days to Taylor. On day 21, Alex discounts the note to a bank at, I shouldn't say 4, but at 9.3%. So we want to find Alex's proceeds. What is step 1? Yeah, find the maturity value of that original simple interest note. How do we find it? .078, yep. Perfect. So our principal, 9,800, times our rate of 0.078 times 120 over 360, 254.80. Do you guys get $254.80 for the interest? Took a few shortcuts. Are we done? Okay. Maturity value is the principal plus interest. So I have to add that to the 9,800. So that is $10,054.80. That is the maturity value. What's our next step? Find the discount period. How do we do that? Okay, good. We have a 120-day term, right? From that, we're going to subtract the 21 days gone by because it was on day 21. That leaves us with 120 minus 21 is 99 days left. That is the discount period, 99 days. What's step 3? Find the bank's discount, which is just I equals PRT. What do we use for P? Perfect. Use that maturity value, the 10,054.80 cents. What's our rate? 9.3, so 0.093%, or 0.093 is our rate. And our time? 99 days, so 99 over 360. So 10,054.80 times 0.093 times 99 over 360. Gives me 257.15. That's the bank's discount, correct? Is that what you got? Perfect. What is step 4? Find, and this is Alex's proceeds. Alex's proceeds is simply going to be that face value, which was the maturity value of the original note, minus that bank discount, 257.15, which is going to give us $9,797.65. Now, a couple things I'm going to point out here. One, how much was the original loan for? $9,800. Alex lost $2.35 in this whole process. So there are two things. One, Alex probably wasn't in a state where he should have been lending out money. If he needed money within 21 days, he probably should have saw that coming. Two, Alex was a little desperate to discount this to the bank, or it didn't charge enough interest on the original loan. But if there's that big of a gap between the amount of interest that's being charged on the simple interest note and the amount that the bank's going to charge you on the discount note, somebody screwed up. And either, like I said, either Alex didn't charge enough interest on the original note, or Alex was really desperate and just let the bank charge him a high rate just because he needed the money. Time for you guys to try one. So let's say Frankie extends a $7,000 simple interest note at 8.1% for 110 days to Bobby. On day 64, Frankie discounts the note to a bank at 9.2%. Find Frankie's proceeds. I'll give you guys a couple minutes. So there's a couple of you still working on it, but let's see how you've done so far. Step one is maturity value of the original simple interest note. How do we find it? $7,000 times 0.081 times 110 over 360. Gives 173.25. Then of course we have to perfect. We have to add the interest of $173.25 to the principal of 7,000. Get $7,173.25 is our maturity value. Yes. The answer key. Oh yeah, use the answer key. Yeah. For a second, like, answer key? How do you have the answer key? It's getting late at night. The little hamster is not on the wheel anymore. He's laying beside it trying to swat it with his paw. So anyway, what's step two? Discount period. Good. How do we find our discount period? Perfect. It was a 110-day note. 64 days have gone by, so subtracting gives us 46 days left. That is our discount period. Now I'm going to warn you, when we do Unit 3 test, that is the single biggest mistake people make on that test, is they find the number of days that have gone by and they use that as the discount period. They forget to subtract it from the total days. Now, in some of the examples we do coming up, you'll see why that can be confusing. So far, we're keeping it simple, so it's relatively obvious that you have to subtract. But coming up, it does get more confusing. What is step 3? Bank discount. And we do that by perfect. We have our maturity value of that original note is our face value for the discount note. The bank's discount rate was 9.2%, so 0.092, and the period was 46 days, so 46 over 360. Multiplying that out, 1173.25.092 46 over 360. $84.33. $83.32.5 if you wanted to leave it that way for now. Then last step. Perfect. Find the proceeds. We take that face value or the maturity value of the first note, 7173.25, and we subtract that bank discount. So $7,088.92 is how much the bank gives out. What do you think? Good stuff? But wait, there's more. On June 21st, Elon extends a $8,500 simple interest note to Aaron at 8.3% for 150 days. On August 7th, Elon discounts the note to a bank at 9%. Find Elon's proceeds. Now, obviously the difference here is I gave you dates rather than days. What is June 21st if we look up our little calendar? 172, good. August 7th? 219. Okay. Step one here is still going to be finding the maturity value of that simple interest note. Nothing is going to change here. Interest is going to be the $8,500 principal times the 0.083 for the 8.3% times 150 over 360. $293.96. Turn $93.96 for our interest. Does that look right? Okay. Maturity value then is the $8,500 principal plus the interest of $293.96. $8,793.96 is the maturity value. Next, step 2 is still find the discount period. And it's on this type of problem that on this step, people make a lot of mistakes. Yeah, there's 3 numbers to deal with. Well, this started, first thing we're going to find here, because we're not given the days gone by, we have to find the days gone by here. And that's going to be found by subtracting August 7th of 219 minus the June 21st of 172, which is what, 47 days? Perfect. So then we find the discount period. Bless you. So then we find the discount period by taking, what was the term of the note? 150 days term minus the 47 days gone by to get 103 days left. That is the discount period. So many people will go with the 47 once they subtract those dates. You got to remember to subtract it from the term of the note. Okay. Step 3 then is still the bank discount. So we get the 87.93.96 times, what was the discount rate? 9%, so 0.09 times 103 over 360. Good. 8793.96 0.09 103 divided by 360. 226.44. Sorry, I didn't mean to cut you off there. 226.44. Then finally, proceeds. How do we do those? Perfect. 8793.96 minus 226.44, giving us $8,567.52. Perfect. What do y'all think? The discount period, you're gonna have to be very careful. Well, let's see if you can do one. On March 3rd, Kim extends a $7,500 simple interest note to Stacy at 7.7% for 100 days. On May 2nd, Kim discounts the note to a bank at 8.9%. Find Kim's proceeds. I'll give you a few minutes. So we need to find maturity value of the original simple interest note. I equals 7,500.077 times 100 over 360. $160.42. So the maturity value, we take 7,500 plus that, $7,660.42. How many of you have it so far? Show of hands. Any questions on that first step? Okay. Step 2. What do we need to do? Discount period. Okay, May 2nd is 122. March 3rd is 62. So yes, we do subtract. 122 minus 62 is 60. That's days gone by. Then what? 100 minus the term of the loan of 100 days minus the 60 days gone by. Give us 40 days left. That is our discount period, 40 days. Then what? Find the bank's discount. And we use I equals, perfect, the maturity value of the original note, the 7660.42 times the 8.9%, so 0.089, and 40 over 360. $75.75. The bank's discount. And then perfect. Find our proceeds. That maturity value of 7660.42 minus our discount of 75.75. So $7,584.67 sound right? Okay, it is time for our second break. When we come back from break, we're going to do a few, I'm going to have you guys do a few examples of different types of problems from tonight, maybe one from last week, and then we'll call her a night. So let's say that Sam borrows $7,400 on a 6.8% simple discount note for 105 days. Find the effective rate. I'll give you guys a minute or so to work. What would our first step be? Find the discount. And we do that by using what? $7,400. Perfect. 0.068 for the 6.8%. 105 over 360. $146.77. What's our next step? Okay, find our proceeds. So yes, it's 7,400 minus the discount of 146.77, which is $253.23. Does that look right? Okay, what is next? The effective rate. And to do that, we use 146.77. The discount becomes our interest. The 72.53, our proceeds, becomes our principal, times R times 105 over 360. Where do we go from there? Perfect. We combine the 72.53.23 and the time of 105 over 360. You get 215.53. Again, we're going to leave that in the calculator so that when we divide here, divide by the 2115.53, we get that R equals 146.77 divided by that previous answer. 0.069378. So again, we move the decimal point 2 spots to make it a percent, 6.9378%. Then we round it to the hundredth, which is the 3. So that 7 says this goes up to 6.94%. Any questions there? Cameron borrows $5,000 at 8.2% for 60 days. For 60 days on June 18th. On July 15th, Cameron pays $2,000. Find 1, the balance due at maturity. Come on. My pen will work. See if that works. Nope. Well, we'll just try to do it with my finger here. At maturity, I know that's more ugly, but that's okay. 2, total interest. And 3, the amount saved by making the partial payment. I'm going to pause this while you guys work on that. Hopefully. So our first action is day 27. That's from June 18th to July 15th. It's 27 days if we look it up in the chart and subtract. So our interest will be $5,000, 0.082 times 27 over 360. giving us $30.75 in interest. So we add that on. 5,000 plus $30.75. $5,030.75 is the balance before the payment. Subtract $2,000 payment, giving us $3,030.75. This is our balance after the payment. So now this is a 60-day loan. So now we go to day 60. That is maturity. The days are 60 minus 27, or 33 days. Our interest is found on that previous balance of 3030.75 times 0.82 times 33 over 360. Giving us 2278. So we will add that to the 3030.75. $3,053.53 is our balance due. So that's part one. Part two, total interest, $53.53, adding up the 22 and the $30.75. Last thing, the amount saved. To do the amount saved, we have to take that $5,000 times the 0.082 times the full 60 days out of 360. Give us $68.33. Would have been the interest had there been no partial payments. So we subtract the 53.53 to get that they saved $14.80 in interest. What you got? Cool. One more problem to try. On November 29th, PAD extends a $6,500 simple interest note to Cam at 8.9% for 90 days. On January 4th, Pat discounts the note to a bank at 9.5%. Find Pat's proceeds. I'll give you a couple minutes. So our first step is to find the maturity value of the simple interest note. That'll be the $6,500 times the 0.089 times 90 over 360. Give us 144.63 is the interest. So maturity value 6,500 plus the 144.63 equals $6,644.63. Step number 2 is discount period. Now, if we look up here, from November 29th to January 4th is how many days? Yep. 36 or 37? Yeah, 36. Okay. So 36 days. Now that could be found November 29th is what? Day 333. We subtract that from 365 to get 32 days there, plus the 4 in January gives us the 36. But that's not our discount period. How do we find the discount period? Perfect. 90-day term. Yeah, I know what you're saying. 90-day term minus the 36 days gone by gives us 54 days left. That's the discount period. So then the bank discount. So yes, our maturity value of 6644.63 times the 9.5%, 0.095. Perfect, 54 over 360. So 94.69. And then finally, the proceeds. So we take that maturity value, 6644.63 minus $94.69. $6,549.94. Cool. Everything that we have done so far has been simple interest, whether it was simple interest note or simple discount note, it is still simple interest, which means that we start out with a beginning balance, which is our present value, and there's one period gets us to our ending balance or that future value, and in between there, interest is added in only at the end of the period, or if there's an action. But if there's an action, we treat it as separate periods, right? Well, our next step next week is to talk about compound interest. Now, of course, with simple interest, money gets put in or out at the beginning, and then money gets put in or out at the end. You know, if it's a loan, money is pulled out at the beginning and then paid back at the end. If it's an investment, money is put in at the beginning and pulled out at the end. Money does not come in or out at any other time in the middle of that period. They said when money comes in or out, it starts a new period. For compound interest, we have our present value, we have our future value. The difference is going to be the term is broke up into several periods. And on each of those periods, interest is added. And of course, the interest that is added in then gets added to the base amount to calculate the interest for the next period. You guys get the point. I'm not going to draw all those arrows in. But still, money goes in or out at the beginning. So if it's an investment, money gets paid in. If it's a loan, money gets taken out. And in or out at the end. There is no money added or taken out anytime in the middle of that. The only thing that's going on is that interest every period. That's what we're going to talk about next week. The third type of situation is going to be an annuity or a sinking fund. An annuity or sinking fund, again, have a present value and a future value. Just like compound interest, there are several periods in between, and interest is added at each of those periods, at the end of each of those periods. The difference is in that annuity or a sinking fund, money also gets paid in and out at the end of each of those periods. So if it's an investment, you pay in at the end of each period. Or if you're drawing out in a sinking fund, you pull money out at the end of each period. Now, a sinking fund can also be used for calculating loan amortization as well. That's going to be 2 weeks from tonight. We're going to actually take 2 weeks on that. That'll be the end of Unit 3, is those annuities or sinking funds. Apparently my A ran away. There we go. So you have something to look forward to for next week with the compound interest. We have our first quiz of Unit 3 here. There's a new quiz that'll be due tomorrow. That's Thursday, 11:59 p.m. And new homework due for next Wednesday. I'm letting you out here a little bit early tonight. It's not like me, but probably.